The next question is, offer a perfectly elastic collision of two identical balls, one of which was initially at rest. The velocity of the both the balls are non-zero. The angle between the final velocity in the lap frame is, so there is a one ball which is initially at rest, then another ball is colliding with this ball. So after collision, the ball will move. One ball will move these directions. One ball move this direction. The angle between these two balls is theta. So we can take the angle of first ball is theta 1. The second ball is theta 2. Both of them masses are same. This is after the collision. This is before collision. These two. One is straight, another one is moving with the velocity u. You can take the final velocity of the both the balls are. You can take one as v1, another one as v2. You have to apply some conservation law to get the relations or the angle between the final velocity between these two. Because it's elastic collision, you can think what is the angle. Even though we can derive, then we can finally conclude what is the answer exactly with for the perfectly elastic collisions. First, we can write the conservation of momentum of these two. Before collision, the conservation of momentum is mu is equal to, after the collision, m1 v1 v1 cos theta, the projection angle, plus m1 m2 are same, so m velocity of the sun ball is v2 cos theta 2, this cos theta 1. This is conservation of momentum in the x directions. So x direction conservation of momentum. Now we can calculate conservation of momentum in the y direction of this frame. Y direction, there is no initial velocity in the y direction. This is 0 left hand side. So right hand side is the vertical velocity of this object. The vertical common velocity of the first ball is v1 sin theta, mass is m, minus, because it's a this vertical velocity pointing downward, so minus, mass is same, velocity is v2, the vertical component of the second ball is sin theta 2. These are the conservation moment of x direction as well as the y directions. Before as well as after the collision, the conservation of momentum we have to satisfy. Now we can do the conservation of energy. We can take this equations is 1, this equation is 2. Now we can do the conservation of energy. Conservation of energy for the elastic collision, this process. Initial velocity u, so the initial kinetic energy of the ball, moving ball of mass is m, velocity is u square. The final kinetic energy of the two objects, the first object takes half m v1 square plus half m v2 square. Or else you can cancel half m on both sides. So u square equal to v1 square plus v2 square. You can take this as a first equation. Already we took 1 and 2. This you can take as 3. Now square the first equation and then square the second equation, sum these two. For squaring the first equation left hand side, m square u square equal to right hand side m v1 square, m square v1 square cos square theta 1 plus m square v2 square cos square theta 2 plus 2 m into m square v1 v2 cos theta 1 cos theta 2. Same we do the second one. Now we are going to doing this process. The first one square we took, same way the second equation square is left hand side is 0, right hand side is m square v1 square sin square theta 1 plus m square v2 square sin square theta 2 minus 2, because one component is minus sign, m square v1 v2 sine theta 1 sine theta 2. If you're summing the left hand side, you will get m square v square. Right hand side, cos square theta 1 sine square theta 1 1. So m square v1 square. The second terms we are summing, cos square theta 2 sine square theta 2 1, m square v2 square. If you are summing these two, take the common term out, 2 m square v1 v2. Inside is cos theta 1 cos theta 2 minus sine theta 1 sine theta 2. Cancel all the m square. So here this is u not v. U square equal to v1 square plus v2 square plus 2 v1 v2. We can use trigonometric identity here. Cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 is cos theta 1 plus theta 2. So u square equal to v1 square v2 square plus 2v1 v2 cos theta 1 plus theta 2. We can check at what condition this equation will satisfy the equation number 3. Mathematically, if you are checking, the cos theta 1 plus theta 2 is equal to pi by 2, because cos pi by 2 is 0. So this term goes to 0. The equation number 4 will satisfy the 3. We can conclude the angle between the two ball after the collision is theta should be equal to theta 1 plus theta 2. That should be equal to pi by 2. This is the answer. The option is 1. So for perfectly elastic collision, if both of them are identical balls, the angle between the two objects always after the collision is always pi by 2 for the perfectly elastic collision if the objects are identical. So the angle after the collision between the two is always 90 degree.